Projectile motion is a two-dimension motion. This is resolving into vector component. We have the y and the x-axis. Now, in a projectile motion, an object travels through a parabolic path through this trajectory with an angle inclined at theta. Now, its initial velocity of taking off vertically is u sine theta. So v is u sine theta. No, sorry, u is a projectile motion is a two-dimension motion resolving into vertical and horizontal component. We have the y and the x-axis. Now, this is an object traveling from point 0 and following through this path down to this point. Now, this route in which it took, this trajectory is parabolic. We'll be coming to deriving parabolic equation of a projectile motion. But as for now, let's see how we can derive the following equation. Now, first thing you have to understand the whole concept of the graph. Now, this object took off from here with an initial velocity u sine theta as inclined to the vertical. Now, on resolving, vertical movement is u sine theta. For the horizontal, it is u cos theta when resolving in vector quantities. Now, this object traveled from this point, it got to this point. At this point, the velocity became 0 because on moving here, there was a change in velocity with time. On moving here, there was a change in velocity with time. But when it got to this maximum height, there was no change in velocity. So velocity becomes 0 and the object now returned back. No, on resolving, we discover that the v velocity becomes 0 and u is given as u sine theta. And from our first equation of motion, which is v is equals to u plus at, you shouldn't forget a is equals to negative g acceleration due to gravity. So on doing that, we're going to just substitute and get the plugin. Where we see v, we put 0. Where we see u, put u sine theta plus a. We're not going to have a plus sign. A is equal to negative g. So where we see a, we're going to put a negative g. So we're going to have negative gt. Now, we are going to take the negative g to the left hand side. We're going to have gt equal to u sine theta. Now, we're going to make t to be the subject of formula. So t becomes u sine theta over g. It is the time it took the object to get to this maximum height we had just derived. Now, the total time of flight, or the time it took the object to move from here to here is time to reach maximum height. This is the time to reach maximum height. Now, the time it took the object to travel from this part down to this place, what we call time of flight. So, or total time of flight, we're going to use from this, we have used the first cardinal point, which is the first equation of motion. Now, interestingly, we are going to be using the second equation of motion to derive every other equation as related to projectile motion. Now, from the second equation of motion, we have s is equals to ut plus half at squared. We're going to resolve. Now, time of flight. Now, the change in height from this place to this place, there was change in height until we go to the maximum height, and the height began to reduce until when it got to this point, the height becomes 0. Now, x is represented as the height, the h. So at this point, when the object got to this place, time to reach total time of flight, s becomes 0. We resolve that s is 0. But remember that u is also u sine theta, a vertical movement. And you should also not forget that a is equal to negative g. Now, let the small t becomes capital T to represent total time of flight. So now on plugging in this, we are going to have s equal to ut plus half at squared Where we see s, we introduce 0. Where we see u, we introduce u sine theta. And when we see t, we introduce capital T, because that is what we are looking for. Negative half, now because of the a, half gt square. Now we're going to take half gt square to the left hand side where 0 is standing, and we're going to leave this at the right hand side. And we're going to have this half gt square is equal to u sine theta t. Now half gt square is the same thing as saying half multiplied by gt square, which is going to give us gt square over 2. So we rewrite what we have here above. We're going to rewrite this as gt square equal to u sine theta t. So we're going to do a cross multiplication. Whenever we have an equality sign, we cross multiply. This will multiply this, this will multiply this. It's going to give us gt squared equal to 2u sine theta. We're going to make the t which we are looking for, to stand alone, and we're going to be dividing through by gt. G will cancel out g, and t will cancel out t, and reserve a 1t, and divided by gt is equal that this t cancel this t. We're going to be left with t, this leftover t, equal to 2u sine theta over g. Now there is also a plugin. We can say that from here to here time to reach maximum height, and from here to here total time of flight. We can also say that t is equals to 2 multiplied by time to reach maximum height. If you notice, from here to here is the same as from here to here. So on doing that, we're going to be having t is equal to 2 multiplied by u sine theta over g. Not forgetting that this t is what we have already gotten here, and it's still going to give us 2u sine theta over g. Now, how do we solve for maximum height? Let me clear out some space. We should not forget, and like I said, we are going to be using second equation of motion to do the same solving. Now we are looking at maximum height. How do we solve for maximum height? Now from the diagram here, this is the maximum height, and let the x represent maximum height, because actually there was actually a height, and u is u sine theta. Then a is equal to negative g. There was a negative g movement. Now let t, now the time it took to arrive at maximum height was already solved, and is given as u sine theta over g. So we're going to be using that time that it took to get to maximum height. Now doing the plugin using from this equation, s equals to u t plus half a t squared. This is what we're going to have. When we see s, we put h is equal to u sine theta multiplied by t u sine theta over g minus half g multiplied by u sine theta over g. Remember, the t is squared, we square it. So h is equal to u sine theta multiplied by u sine theta, going to give us u square, that is u multiplied by u square. Sine theta multiplied by sine theta is going to us sine square theta over g negative g, negative half g multiplied by, let's open the bracket, this will become u square sine square theta over g square. Now if you can check, we have a g here, we have a g here. This g divide with this, and this g becomes 1. So h is equal to u square sine square theta over g minus this is what happened, g multiplied by u sine square theta is going to be g u, no, this g has already been cancelled, sorry, this g has already been cancelled out. 1 multiplied by this is going to give us, and now this was going to happen, 2 multiplied by the denominator. The denominators are going to be multiplied by the denominators. Okay, let me just make it clear. 1 multiplied by u sine square theta over 2 multiplied by g. Okay, this is what we're going to have. H equal to u square sine square theta over g minus 1 multiplied by this is going to give us u square sine square theta over 2g. Now we're going to take LCM for g and minus and negative 2g. This is what we're going to have. 2g is the LCM. 2g multiplied by g. You know, when 2g dividing by g is going to be left with 2. We multiply the 2 by the numerator. We're going to be having 2u square sine square theta minus, now this 2g divided by 2g, if 2g is dividing 2g, you know we're going to be having 1. So the 1 we multiply by the numerator here at the top. This 2g divided by this is going to give us 1 multiplied by this. It's going to be giving us u square sine square theta. Now if you notice they are the same, just that this one is 2 and this is 1, we're going to subtract. On subtracting, we're going to have h max as u square sine square theta over 2g. This is how to derive maximum height. This multiplied subtracted by this, we got this. Now let's look at range. Let me clear up some space. Now this is the range, the maximum horizontal distance. So range is giving us uxt, but don't forget that ux is u cos theta. Now there's a t here, you know, it's a distance time, so rho is equal to u cos theta. Don't forget that ux is u cos theta multiplied by the t here is 2u sine theta, 2u sine theta over g. That is the time to reach maximum height. Time to reach maximum height. Then we're going to do a multiplication here, an expansion. R is equals to, we're going to be having u times u square 2 sine theta cos theta over g. Now, but when we have 2 sine theta cos theta, it equal to sine 2 theta. So when we see this 2 sine theta cos theta, we replace it by sine 2 theta. So rho is equal to u square sine 2 theta over g. That's how to find range. Your maximum range is giving us u square over g. Hope this video is helpful. If it is, please subscribe, like, share, and also drop your comment. Thank you very much.